All right, back to our text normalizer module. So we wanted to implement the rest of the functionalities, and we only have two of them remaining, which is the lemmatized text and the stem text. And as we have already, and we actually got deeper understanding of what they really do behind the scenes. We're now going to implement them using NLTK. But before I actually go ahead and implement functions inside this class, I want to go ahead and create a separate cell. I want to actually go ahead and create like a playground code for experimenting the functions we have available in NLTK library. So the functionalities we can access from NLTK is by saying from NLTK dot stem. So for stemming, I'll actually go ahead and import something called Porter stemmer. And for lemmatization, we have something called the word net lemmatizer. And again, the word itself, this word net lemmatizer itself, the spelling, this terminology itself explains us that it will be using the word net corpus for comparing and analyzing the text. So now what we will do is we'll just go ahead and create the instances for them. So I'll say ps equals Porter stemmer, and here, and then we'll say WNL, short for word net lemmatizer, and here I'll just say word net lemmatizer. Okay, great. Now I'll just go ahead and create this. First of all, what I want to see is what exactly does how do we actually go ahead and stem or lemmatize words using these sentences. So first of all, let's just go ahead and use the Porter stemmer to stem our texts. Okay, so I'll just go ahead and say, first of all, I'll just go ahead and create a simple word, and I'll say I'll use the same word that we just used as an example in our explanation. And now I'll say ps dot, and the function that we use for this is called stem. And as you can see, it says that it receives just a word, right? So I'll just pass in the word like this, and then I'll just print the, so what, I'll just go ahead and print this inside here and say stem. Okay, and like this. And so oh, I forgot the comma here, and now I'll run this and see what happens. And as you can see, as we discussed earlier, that it's actually going to go ahead and chop off the ATION from renovation, and it will actually go ahead and give us the word. But what if we now do this the same thing and lemmatize the same word, and let's see what we get. So I'll just go ahead and copy the same thing, and here I'll just say I want to get the lemma from lemmatizer, and I'll use something called WNL, and the function that we use here is lemmatize. And I'll just run this now and see what happens. And as you can see, it says stem, so the stemming actually gives us renov, and the lemma gives us renovation, and it's indeed correct. So that means the word net lemmatizer must have gone to the word net corpus and must have not found this word renovation, and therefore it knows that this is not an actual word. And now you can, and that's why you can see that it was not lemmatized. Now so now since we need to actually implement this inside this class, and since these functions only receive individual words, we need to have we need to create a logic where we could just loop over a text. And first of all, obviously what we can do is we can tokenize our text and pass in individual list of words inside this lemmatized function and get the lemmatized or stemmed words out of them, and then finally join and return the text, right? That's what we will be doing. But one thing that I needed to actually show to you is that the lemmatize function will not work on a lot of other examples. So for example, if I pass in an actual word like staying, now theoretically you know that this word converted into stay when you pass into the lemma, right? And so if I just run this now, as you can see, it does not convert into stay. And the reason for that is because the lemmatize function receives something called the parts of speech tag. So I'll just go and quickly pop the help of this function lemmatize, and I'll just say help. So if you want to actually go ahead and find out the variables that a particular function receives, we can just go ahead and quickly pass in the help, and it gives us, okay, you can see that it's giving us the description. And here you can see that the lemmatized function receives a word, and it also receives a parts for speech tag. And as you can see, the parts for speech tag is actually basically just telling the lemmatizer whether a word that the word we are passing here is a noun or a verb or an adjective or an adverb. So we need to specify that so that it knows what kind of word are we really passing into it. So now, for example, if I pass in a parts of speech tag here, so we know that the staying is actually a verb, it's an action. So if I just pass in the v here, let's see what we get. So I just run this now. Now you can see the lemmatization works. And so now you kind of get the idea that we need to somehow create a logic in which first of all we tag each and every single word in a sentence, and then finally we pass in the tag and the word to the lemmatized function, and then the lemmatization is going to work properly. But on the other hand, we don't need to do anything with the stemmer. It's going to work right away. So now let's get started with implementing this inside our class. Okay. So what I'll do here is, first of all, I'll create an instance of both of these things. Okay. So if we go up here, okay, so I've already created an instance for both word lematizer and a stemmer, as you can see. And I've just done nothing. I've just created a variable, and I've just stored this into the self.wnl variable, and therefore we can access both of these variables in the whole class, right? So what I can do now is I can just call this right away in the lemmatized text. But first of all, what I will do is I will just go ahead and implement a logic. Okay, so I'll assume that I have a function called tag text, and we will actually go ahead and tag our parts we will tag our sentence using the parts of speech tag. So I'll say pos underscore tagger. Now obviously we don't have this function yet. We'll implement this. So I will just call this self dot pos tag, and I'll pass in the text here. Okay, and now once you get the tag text, what do we want to do? So I'll assume what we need to get as an output would be something like this. So I'm just going to go ahead and comment out something like, so what we need in the response for this one is that we need a list of tuples where first, for example, we have a word and we have parts of speech. Um, we have what's happening to my typing. So yeah, this is the form that we really need, right? So we need a word and a parts for speech tagger. That's what we really want to do, right? So then what we can do further with this kind of list is we can just go ahead and use a simple for loop to lemmatize and pass in word and the parts for speech tag one by one into this function wnl lemmatize, right? So now what I will do is I'll just say lemmatize um, underscore tokens, and then what I can do is I can say um, so I'll say wordnet lemmatizer. So I've already created this. Oh, so we need to use a self, otherwise it won't be accessible. So I'll say self dot wnl, and here I'll say lemmatize, and there I will pass in the word first of all and the pos tag. So now remember, I haven't implemented this function yet, so don't worry if you're not able to understand this. Once I implement this function, you will understand what I'm saying, okay? So now I have specified the word and the POS tag. So now what I want to do is I want to say if POS underscore tag. So what I want to get in the response is, so if you don't have the POS tag in response, what we need to be able to do is we want to pass in the none. So if nothing is actually responded, we will just return the word itself. Otherwise, we will return the POS tag in here and the word as well, and then we will lemmatize it further, right? So that's what this if condition means. And then finally, what I will do is I'll say for word. Okay, I think you guys can see this. Okay, now so say for word dot for word comma pos underscore tag in tagged underscore text. Now this is the variable that this is the list one what I'm really accessing here. Okay, and then finally I can simply say so I'll say lemmatize text. So we need to just join the tokens together in a form of a sentence. So I can just simply just say I'll put a space here and say dot join, right? And now this is very simple. We can just put in like lemmatized underscore tokens, Okay, and then finally return lemmatize underscore text. Okay, so right now this is not going to work because we haven't implemented this function yet. So now let's just go ahead and implement this function. Okay, so I'll say def underscore so pos underscore tagger, and here what I want to pass in is the text only, right? And we also need to pass in the self because we want to be able to access some of the functions of class. And as you will see further, that I want to use some of the functions here. Okay, so first thing that we need to understand is why do we really need to why do we really need this function? Okay, so currently as we realize that our function lemmatize here receives two things: the pos tag and the word itself, right? And what we can do essentially is we can pass in the tag along with the word, and the lemmatizer will automatically know what to do with that word, right? So what we can do, so we need some sort of a utility that could simply tag our words in a parts of speech tag. But one thing, and the function we have available, if we have a function available in NLTK that we can use to tag our words. So what I'll do, I'll just call a function called NLTK. Actually, I don't even need this, right? So what I'll do is I'll just go ahead and call. Let's suppose I have a word, so I'll just do one thing, okay? I'll just pass it NLTK dot POS underscore tag. Now this is a function right here in NLTK that we can use to tag our word, and you can see that it actually returns something like this, as you can see. And the POS tag can take strings for us, right? So it can take the string of text. So if I just say like hello, I am Ali, and if I just run this right now, one thing that you notice is that this is not going to work because, again, we just saw that this POS tag receives the tokenized text and not the raw string. So we need to pass in the list of words. So what we can do essentially is we can use the NLTK's word dot underscore tokenize module to tokenize our text, and I will say that NLTK dot word underscore tokenize, and then pass in the text inside this and we will get the list of the words, and then finally we will pass that list to the POS tag. So now when I run this, let's see what we get, and now you can see it works. And now it's going to be a little bit hard to understand since so the kind of tags that POS underscore tag returns us are called the Penn Treebank tags. And I've actually pulled a list for you guys from this great website upenn.edu, and this actually shows us all the different types of tags we have, and each of these tags actually represent something, right? So we have like, so first of all, so for example, we have something like NNP, which represents a proper noun, right? And so we have a lot of different definitions. And the problem we have here is that so if you take a look at this word underscore lemmatize, we don't really pass in a tag like this. We're not passing in Penn Treebank tags into this function. Instead, we're just passing in very simple characters like so V represents the verb, A represents an adjective, and so on. So we want to be able to somehow we want to create a logic or a map that we could use to actually convert our Penn Treebank tags into WordNet tags. Okay, so what I will do now is I'll just go ahead and do that by creating a tag map. Okay, so I'll just use a dictionary for that, and I'll say tag underscore map, and here I'll just pass in like, okay, so the kind of tags that we have are, first of all, it's J. So after doing a little bit of research, I kind of got to discover that we can use some of the tags like, so if a tag starts with a J, what we need to do is we want to just say, so Penn Treebank, that all the Penn Treebank tags that start with J are supposed to be adjective, right? So you can see that it says the J starts with, so if it starts with J, it's an adjective, and you can see all of them are actually adjective, right? And then, so if anything starts with R, it's an adverb, and if anything starts with V, it's a verb, right? And so we can actually go ahead and kind of use the logic where we could just extract the first character of the tag and find out whether a particular thing is a verb or an adjective or a noun. So we can use this logic. Okay, so now what I will do is I'll just go ahead and I'll go back to my original example, which is tag map, And now, first of all, I want to go ahead and call the wordnet. Okay, so what I can do is I can use the wordnet by saying self dot wn equals NLTK dot corpus dot, I don't know exactly which what was the exact word, so I'll just say NLTK dot corpus dot, so I'll just go ahead and say NLTK corpus dot word net, and I think this should kind of work. Yeah, I think this is the one. So I'll just make this. Now I'll just run this one, and obviously we get error because we're not using the right syntax. And now what we can do is we can access, we can use the wordnet tags here. So if we have J, what we can do is we can say the wordnet.adj. So this stands for adjective, and this will automatically return the the A for us, which stands for adjective, right? So we can kind of do this now, and we can do the same for the rest of the pass to speech. So we'll say, so if it starts with v, it means it's a verb, so I'll say wn dot, and here I'll just pass in verb, comma, and then again, now, and then if it starts with n, you want to say wn dot, and it will say noun. Okay, and then finally, um, and if it starts with r, it's an adverb, right? So we can say wn dot adv. Okay, so now we have created our tag map. So now we want to be able to now, first of all, um, tokenize our text, and then replace the tags that we get from the POS underscore tag function that we explored here, and then convert them or use the dictionary to map or replace the tags with these ones, right? So now what I'll do is I will say text equals. So in order to first of all tokenize our text, we can use the function that we just implemented here, which is the tokenized text, and this gives us the token, right? So I'll just say text. So I'll say self dot tokenize, and here I'll pass in the text. So we get the tokens from this, and then finally what I'll do is I'll say tag underscore text, and here I'll say NLTK.POS underscore tag. We'll use the same function, and here what we will do is we'll pass in the same text, which was tokenized originally, and then finally, what we want to do is just go ahead and add some little space here, and then finally, what we want to say is we'll say tag underscore um, tag underscore. So I'll just go ahead and say something like wn underscore tag. So we want to convert the Penn Treebank into wordnet tags. So I'll say wordnet.tagged.text, and also, yeah, so I think that's good. And then we will say, so one thing that I want to make sure is that you don't end up with any capital words. So I will actually go ahead and convert them into a lowercase. So I'll say word dot lower, and here I'll just pass in. I think so we don't really need this. So word dot lower, and then so we have the tag map, right? So we'll say tag underscore map, and then here I want to pass in my POS tag, right? So we have the POS tag available like this, right? So first of all, we'll just say zero. So it's zero. So what I'm doing here basically is I'm just getting the first word from this tag, right? So we're getting the first character. I'm sorry, the first character from the Penn Treebank tag, and then we are just passing it into the tag map. It will match the key like J, V, or N or R, and it will return the corresponding wordnet tag for our Penn Treebank tag, and that's what I've done here. Okay, so once I'm done with that, what I can do essentially here is, I think that's good enough. Yeah. So, and then I'll just close this now, and I'll say for word, comma, POS underscore tag in, for word comma pos underscore tagged in tagged text, right? So I'll say tag underscore text, and I'll just close this now. So I think we're almost done with our thing, right? So I think that's exactly what we really need to do. Yeah, I think we're good to go now. Okay, so now what I've done here is I've actually used a list comprehension, and I've just converted our tags into the WordNet tags, the Penn Treebank tags into WordNet tags, and then I'm just pushing them back into the WordNet text, and this is now tagged with WordNet tags, and this list can be returned back as follows by saying this return wn underscore tag text. So I think we're good to go now. So now I'll just go ahead and run this, and nothing wrong with this. So now I'll just go ahead and try to actually call this function here, lemmatize text, and see if this actually works or not. So what I will do is right here where we have called the text normalizer, I'll just go ahead and comment this out for now, and I'll just say tn dot lemmatize text, and here I'll say I am running. So I'll just run this now, and let's see what we get. I'll just go ahead and print this, and let's see what we get. Okay, so we get an error. It says, um, I think we do have some error here, and it says that keyword error P. Okay, so um, let me see exactly what's happening. Okay, so I just realized that the reason why we are getting this error is because we obviously do not have just these four Penn Treebank tags, and obviously if we pass in some other things like M or I, they might correspond to some other Penn Treebank tags that we haven't defined in our tag map, and therefore we want to be able to first of all have a logic where we could just say if anything else occurs in this dictionary that does not exist in this dictionary, we want to return none. So what I can do here is right here I can just say if, so we're getting this pos underscore tag. So this is the key that we are searching for, right? So I can say if this exists in the tag map, then we want to return this value, right? Otherwise, we can say else, and then we can return something like this. But now we don't want to return the tag maps corresponding value, but we want to return none. Okay. So when we do this, let's see what will happen. So now, if I now save this class right here and run this again, let's see what we get. So now you can see it actually works. And as you can see, the M was converted into B, and staying was stamped to stay. And this is working. So now if I just pass in a very, so if I just say staying, and I run this again, so you can see it gets converted or lemmatized into stay. So it's working great. So now we will actually go ahead and implement the last function, which is the stem text. And the logic is going to be very simple. We'll use the Porter stemmer that we have created here, and we will use this now. So what I'll just go ahead and do is say, first of all, we want to be able to, first of all, break our text. So I will just say, so I'll say tokens equals self dot tokenize text, right? And then here I'll just pass in my text, and then I'll say for, so I'll say a stemmed text equals, and here I'll just return the stem, right? So I'll say so self dot stem ps dot stem, and here I'll pass in my token. So I'll just say token for token in tokens. And one thing that you notice is that when I'm using this list comprehension, my life gets actually very easy. So I would actually recommend you guys to actually use this list comprehension because it makes the life very easy, right? And then what we can do is we can just finally join this. I'll say, so this is actually the token. This is not the text. So I'll just say token, and here I'll just say stemmed underscore text equals, and then I'll just pass in my space dot join, and I'll just pass in the stemmed tokens. Okay, stemmed underscore tokens, and then finally return this stem text. Okay, okay, so I think this is good, and I'll just save this now, and let's see what we get. So I'll just go ahead and apply the same thing over this. What I'll do is now I'll just go ahead and use both of these functions to see exactly how they perform. So first of all, I'll just say I am stay, right? And I'll use the same text here. And here I'll just say stem text, okay? And let's run this now and see what we get. So you can see we get a bit of different results. One thing that you notice is that this one right here, the stem text, kind of resulted in the same way, except for the fact that it was not able to convert the M into B, because again, we're not using any parts of speech here. We're just using simple text processing here. So, so the way it works is different, and we'll be using both of these functions depending on our needs. So we might not need stemming in some scenarios, or we might need both of these in some scenarios. So that's why I've implemented both of these functions. So right now, if they don't work in a similar way, it's okay. This is exactly how this should be. Okay, so now we have actually implemented all of these functions, and so our original goal was to actually to be able to just sequentially apply all these operations together and get the normalized text. So as you can see, I've already curated an example for you guys where we have something like this, and you can okay. So we have something like this, and you can see this is a pretty informal text, and we have a lot of special characters. We have contractions available in this text, and we do have some words that need to be stemmed. So I'll just go ahead and say jumping. So you can see this jumping is actually, I know this sentence doesn't right here does not look like a right or even a grammatically correct sentence, but what we want to be able to do is we want to be able to normalize this whole sentence. So now I'll just go ahead and quickly apply all these operations, and then call this. Let's see what we get. All right. And okay, so this actually did work, but as you can see that it kind of removed the stoppers from our text, like this, and you can see that the lazy is converted into lazy. That is actually very weird. Okay, so we do get the output for this, and so and then we also have the normalizer. You call that, and so the jumping was converted into jump, which means the lemmatization or stemming did work. So what I will do for now is I will not use stemming. Okay, I will just use the lemmatization. Okay, so I'll just say stem equals false. So we don't want to use that currently. Okay, so now I'll run this again to see what we get. Okay, so it says unexpected keyword argument stem. Okay, so that means oh, I pass it in the wrong place. We need to pass it here. So I'll say stem equals false. Okay, so let's run this again to see what we get. Okay, so we do get some stuff here, and as you can see now, we did not converted the lazy into lazi, and this is working. Okay, so now we can kind of get the idea that we have this module ready. So what I would recommend you guys to do is you convert this normalizer module into a simple Python file, and then we can further reuse this in our further project. So now in our next video, we'll be creating a text classifier. We will also be using some of the machine learning models to classify our text, and this module right here, this text normalizer module, will be used in that particular project. Okay, so stay tuned for that, and if you haven't subscribed to my channel yet, do that, and please comment down below if you have any confusions regarding this code. And yeah, so that's it for this video. Thanks a lot.